Hi, fifth graders. It is math note time. Woo! All right, need your pencil, your math notebook. Open up. Look, we're getting close to 50 entries in our math notebook. Pretty cool. All right, so today, no models with our fractions, just the algorithm. So again, we're going to write multiply fractions. And we can give this one a D3. And today, there's no models. All right. Let's open our book up to page 47. This is multiply fractions, and today it's all about the algorithm that I've already taught you. ALGORIITHM. Multiply fractions, algorithm. All right, so let's get those steps down to our algorithm and then do two examples together. So we have step 1. All of our fractions today are going to have a fraction and a whole number. That's going to be the pattern that we're multiplying together. And because we have that whole number there, step number 1 must be that we change the whole number to a fraction. It's very important you make sure that your whole number is also a fraction. And then the rest of the algorithm is super easy. There's 3 more steps. Step 2, you multiply the numerators. And that makes step 3 then. You already know all of this. I'm sure you're thinking, we're going to multiply the denominators next, because that's what we're going to do. So let's review what we have so far for our multiply fractions algorithm. We have step 1, and when you multiply fractions by fractions next year, this step 1 will drop off. But because in 5th grade we only multiply a fraction times a whole number, this is what our step 1 is going to be. So step 1, we're going to change the whole number to a fraction. Step 2, we're going to multiply the numerators. Step 3, we're going to multiply the denominators. And step 4 would be next, and we're going to simplify our fraction. We will have to simplify. Because we're multiplying a fraction times a whole number, our answers will be improper fractions. And we are going to have to fix those improper fractions by simplifying the fraction. And really, anytime that we work with fractions, whether we add them, subtract them, or divide them, we need to simplify them if we need to. So that should just be something that's ingrained. Last step, check to see if I need to simplify. All right, so let's do our first example today and go through that algorithm. Let me see where I wrote it. Right here. Okay, so our first example is 5 times 3/8. No models today at all. So we're going to take this 5 and we're going to rewrite it. We're going to write 5 over 1 times 3/8. Now, it's important to remember that the simple change you make to this whole number is just give it denominator of 1. That way we don't change the value of the number. We're still multiplying times 5. Once we do that, then we multiply our numerators. 5 times 3 is 15. 1 times 8 is 8. And we think we have an improper fraction, so we have to simplify. So I think, how many times can 8 go into 15? 8 can go into 15 one time. It's not going to make it to the 2 because 8 times 2 is 16. Going to subtract 8 from 15 and I get 7. So I think now I have a remainder. When you have a remainder, you have to write your answer, your remainder as a fraction. And I do that by thinking I have 7 left over out of the 8 parts I was dividing 15 into. So it becomes 7/8. So in our example answer right here, 5 times 3/8 is equal to, dun dun dun, 1 7/8. One more for our notebook so we have 2 good examples in case we forget. So our next problem is 2/3 times 6. Okay, same step. Step number 1, we've got to take care of this 6. So I'm going to go ahead and write 2/3 on my paper because that fraction is already written as a fraction. I'm going to bring my sign down, and then I'm going to make sure that 6 is written as a fraction. I'm going to do that by writing 6 over 1. My next step is to go to step 2 and multiply my numerators. 2 times 6 is 12. And draw my line. 3 times 1 is 3. Now we're left with an improper fraction. And I think, how many times can 3 go into 12? It's going to go in 4 times, isn't it? It's going to be equal with no remainder. Okay, so that means that my final answer is just 4. When you see that that 3 can go into that 12 and you know it's going to be a whole number as an answer, you don't have to write this to figure out all the other parts. Okay, you can just go right to 4. All right, so let's take a look at our practice for today. I'm actually going to go backwards today and start with question number 10. I'm going to do 2 more with you before I send you off to do your practice. There are actually 12 questions on today's practice, so we're going to start in the back, and this is going to be number 12. So if you have notebook paper, you can get it down. Okay, so this one says that Rose bought a dozen eggs. She used 2/3 of the eggs to make custard and 1/4 of the eggs to make an omelet. How many eggs does Rose have left? Okay. Well, the first thing we need to understand is the total number of eggs that she had. And she had a dozen. What number represents a dozen? I hope you were thinking 12. So when I see a problem like that, I just cross out the word version of that number and replace it with the numeric standard form. So Rose bought 12 eggs, is how it reads. She used 2/3 of the eggs, and then she used 1/4 of the eggs to make an omelet. And I want to know how many eggs she has left. Well, we're going to have to figure out how many sets of 2/3 there are in 12 first. So step 1 for this problem is to figure out how many sets of 2/3 there are in the number 12. Or another way to think about it is 2/3 of 12 is what? So 2/3 times 12 over 1 is the problem that we're doing. And y'all see how I took that 12 and I went ahead and when I wrote it and made it as a denominator of 1? Because I knew that 12 was going to have to be written as a fraction. But it's still 12, right? So I'm going to multiply across the top. 2 times 12 is 24. And 3 times 1 is 3. And now I have to see how many times 3 can go into 24. And it's 8. So we know that she used 8 of them so far to make the custard. Okay, so this represents the custard. She used 8. Now step 2 is to figure out how much she used in the omelet. So I got to go back to step 2. And I'm going to use the same process. She used 1/4 of the 12. So we're multiplying 1/4 times 12, figuring out that fractional part of 12. So this is going to be omelet and 1/4 times 12 over 1. I went ahead and combined step 1 when I wrote it. 1 times 12 is 12. And 4 times 1 is 4. 4 can go into 12 3 times. So it looks like for the omelet, he used 3 eggs. She, is it she? Yeah, it's Rose. She's a she. She used 3 eggs. And then for the custard, she used 8. So if we want to figure out how much is left of that 12, we need to add this together. 8 plus 3. What is that? 11. And subtract it from the 12. So it looks like she only has 1 egg left. Only 1 egg? Yep, that's how much she has left. All right, so let's look at another word problem. Word problems sound weird. You feel like you need to divide because you're taking a fractional part of it. But if you think about it, the last step that you have to do to fix any one of these fractions is divide. So ultimately, in the end, in this process, when you're simplifying, you are dividing. Okay? All right. So the florist arranges a bouquet with, oh, sorry, you can't see it. The florist arranges a bouquet with 12 flowers. He decides that 3/4 of the flowers in the bouquet will be carnations. How many carnations will the florist need to complete the bouquet? So again, we're focusing on this number 12. He wants 3/4 of the flowers. How many flowers does he have? He has 12. So you're really thinking 3/4 of 12. Remember, of, anytime you have a fractional part of another number, that represents multiplication in math. Of is another key word in multiplication in math. Okay. So the flowers total he had was 12. He decides that 3/4 of the 12 flowers in the bouquet will be carnations. So of is a clue to multiply. So I'm going to write 3/4 times 12. Now, when I write my 12, what do I need to do to my 12 so I can multiply it? Because it's written as 12 wholes in a word problem. Just like I did up here, I'm going to do 12 over 1. I'm going to do 3 times 12, 36. 4 times 1 is 4. 34 can go into 36 9 times. So 9 of them need to be carnations. Okay? So that would be B on your practice today. Okay. I want to see if I have one that we have to do a simplify on. I didn't realize all these are going to end up. Let's jump up to number 1. I think you're going to have a mixed number as an answer for number 1. I hope. All right, let's see. So let's go through this algorithm for number 1. So number 1 is 3/7 times 4. So 3/7 times, and I'm going to write 4 as 4 over 1. Why? Because I cannot multiply this whole number as it is. I've got to make it a fraction, so I give it the denominator of 1 to not change it. All right, 3 times 4 is 12, and 7 times 1 is 7. So I have an improper fraction. I have 12 over 7, and this is not going to work evenly. So I'm going to divide 7 into 12. How many times can 7 go into 12? 1 time. And that's going to be minus 7. 12 minus 7. Oh, I'm tired. What is 12 minus 7? 1, 2. I'm going to use my fingers. No one judge me. 1, 2, 3, 4, 5, 6, 7. Yeah, 5. When I'm tired, sometimes I have to resort to what I learned in younger grades. It's all right. We all have to do it sometimes. I'm hoping I used it right. So I have 1 whole, and then I have 5 left over out of the 7. So I'm going to write that remainder as a fraction. So that means my final answer is 1 5/7. Please be sure when you write this in, you follow the same process that we did on the other day, where we did the number, right? We did the number 1 on the keyboard. We did a 1. We hit the space, and we used this slash that's underneath the question mark. Oh, wait, we got to do 1 space and then the fraction 5/7. Like I said, I'm tired. I'm trying to help you, but I feel like I'm confusing you. All right, so you need to go into your practice on the next page. You'll have the number 13 and 12 already on your paper, and you'll also have the number 1. So I might just on my paper go ahead and roll to number 2 next. and then go back and fill in your 12 and 13 when you get there. Okay, good luck. I don't know if y'all realized it or not, but you have more than one attempt on each one of these practices. So if this first one doesn't go well, you can go back in and take it again. All right, good luck.